Here we are back on the sample vulnerable web application, and we can currently see the login page. Now I want to give you an example of identity enumeration, and this risk becomes really clear once it's demonstrated. What we want to do in this scenario is establish whether someone has an account on the site. So rather than logging in, what I'm going to do is go over to the Forgot Your Password link. Now to demonstrate the enumeration risk, I'm going to start by entering an invalid email address. So I'll just enter foo@bar.com. Let's try and reset that. And here we have a very clear message. The specified user does not exist. Let's try something different. Let's try my account because I know that I do have an account on this website. So I'm going to enter my email address, and now let's try and reset. This time, your password has been reset and you should receive an email with a new one shortly. So see how we get a different response. One advises us that the account doesn't exist. The other one advises us that the account does exist. So this actually becomes a privacy risk. This website is leaking the identity of members if you specifically ask it if an email address exists. Now for a website like this, that may not matter too much. And what I mean by that is that in a privacy sense, would a member of this website be too upset if others could discover that they were voting on supercars? Probably not. But let me give you another real-world example. In 2015, we saw the hack of Ashley Madison. 37 million accounts were exposed, and there was outrage that this website had disclosed who had an account on the site. But I wrote a piece in July 2015 where I showed that the website would disclose that anyway because the password reset had an enumeration risk. Now, Ashley Madison was a website designed to encourage people to have affairs. Confidentiality is enormously important on a site like that. And the ability for anyone to go and check if anybody else had an email address on that site and consequently draw the conclusion that that person was out to have an extramarital affair is an enormous violation of privacy. So that's an example of where enumeration would be a serious problem. What I'd like to do now, though, is show you a really good implementation that defends against this risk. Let's go over to the EntroPay website. This is EntroPay, and they allow you to have virtual credit cards. So clearly, it is a financial site, and security is going to be paramount to these guys. Now, here's what I'd like to show you. Let's go and repeat the same process as we just did on the sample vulnerable site. I'm going to go down to Forgot Password, and I'm going to go and enter a fake email address. So let me go up to here, and the one I'm going to use is testenumeration@mailinator.com. Now I'll show you why I've chosen that specific email address in just a moment. Let's now go and submit this and see what happens. Okay, here we go. Email sent. We have sent you an email at testenumeration.mailinator.com with further instructions. Now remember, we've just manufactured this email address. It almost certainly doesn't exist as a valid account. The trick here is that if it was a valid account, you'd get exactly the same message here on the screen. Where things diverge, though, is that you'd get a different email. Now, the reason I used mailinator.com as the domain of this email address is because we can now go and check what's in the email box of the test enumeration account. Let me jump over to Mailinator now. Okay, so let's now type in test enumeration and we'll check that email box. And here we can see just a couple of minutes ago we got an email from EntroPay support. Let's go and take a look at what's in that email. And here's an interesting message. You or someone else entered this email address when trying to change the password of an EntroPay account. However, this email address is not on our database of registered users. Now this is great because email ends up being the channel by which the account is either confirmed or denied, not the anonymous attempt to reset the password. And that's really the heart of defending against the enumeration risk. You always have to give the same response whether the account exists or not. Now that doesn't just go for the password reset. It's the same thing with registration as well, because registration facilities often confirm whether an email address is already in the system. You might have seen this before. It says, hey, you've already registered with that email address. You can't register again. And the solution to that is the same. You have to give the same response on the website and then confirm via email whether that account exists or not. That's something I go into more detail on in the Secure Account Management Fundamentals course. Now there's just one more thing I'd like to show you about account enumeration. Let's go and take a look at a graph. This is a graph of login timings, and it shows a really interesting trend. Every single time I tried to log into this particular website I was testing with an account that didn't exist, it responded very, very quickly. So those red bars show that the response came consistently at about 130 milliseconds. Now, every time I attempted to log in with an account that did exist, that timing was always over 500 milliseconds. Now, regardless of whether the account existed or not, you got the same response from the web app. It said, hey, this combination of username and password is not correct. But the timing gave it away. So by observing the behavior of the web app and literally timing how long it took for the response to come back, I could easily conclude whether the account existed or not. The reason this happened is because the web application was using a very slow hashing algorithm. Now, this was actually good news. Web applications should use slow hashing algorithms for their passwords. And we'll talk about that more towards the end of this course. But the risk you then end up with is disclosing the presence of the account, because the hashing was only happening if the account existed. So when you logged on, the web app would attempt to go to the database and pull back the record for the username that was provided. If that record existed, then it would hash the password that was provided and compare it to the one that was stored in the database. If the record didn't exist, it would never hash the password that was provided. Now that's an efficient technology design, but it leads to an enumeration risk because all you have to do is look at the timing of it. So that's all I want to cover here for identity enumeration, but it does speak to those nuances that I mentioned at the start of this module. There are lots of little aspects of identity management you have to get right in order not to have risks like this. Now conversely, as an ethical hacker, there are lots of different aspects of an identity management implementation that you can probe away at and almost certainly find risks.